Hello guys, and welcome back to another episode of chemistry. And of course, today we are going to continue our study of organic chemistry. Most specifically, we are going into esters. Okay, so today we are going to look at esters. Esters. Okay, no H in the spelling, no esters. Okay, these esters, call them alkanoates. Alkanoates, okay? Or we'll just say they are what? Alkanoates. Okay, so you can call them what? Alkanoates, you can call them alkanoates. Okay, they are called what? Esters. Do not forget that this tutorial is brought to you by the one and only O3 School's JAMB practice app. You want to succeed in your exam? Go and get the app. Look at our testimonies from previous years. You will see a lot of amazing testimonies on how people score 300 using what? Our wonderful application. But before we talk about the app in a moment, let's see a question from the app. It's a JAMB question 2013 number 47. It says here that an organic compound, it is being displayed on your screen right now. An organic compound with a pleasant smell is likely to have the general formula. A, you can see CnH2n plus 1, COO, CnH2n plus 1. B, CnH2n plus 1, CO, CnH2n plus 1. C, CnH2n plus 1 CHO, D, CnH2n plus 1 COOH. Okay, so we'll come back to this question and many more questions at the end of the class, because in O3 schools, we believe in giving you value first. All right, let us teach you. Why don't we just teach the students first? When we teach them, then we answer questions with them. They can go by themselves to what? Answer questions confidently. All right, so please get the application. The app has a lot to offer. You ask all the past questions for all subjects in one application, so no need to go and buy past questions. Likewise, there are lecture notes structured according to the JAMB syllabus. Some of you will be studying without JAMB syllabus. You are doing yourself, oh, please do not. So to save yourself the hassles of looking for textbooks to buy, which one should I use? You can use the application. Lecture notes on the application. Then what's more? Question search feature. After studying a particular topic, you can search for question on that topic with the question search feature from the application. What's more? There's also a mock challenge. A mock challenge that will conduct for all students that are writing JAMB for this year. You compete with your mates, win a lot of amazing prizes, and of course, get used to JAMB past questions, JAMB likely exam questions. All right, you see your score released every Saturday, thereby building your confidence toward the main exam. Even when JAMB say they want to do their own mock, it becomes what? A play for you. So please, the app has a lot to offer. Jump on the application, jump on Play Store, download it, and activate it for a little fee. Okay, a little token. Pay the sacrifice, activate. I know what I'm telling you. So let us look at esters today. Esters are called alkanoates, as you can see. So you can so call them what? Alkanoates. Esters have the general formula CnH2n plus 1 COO CnH2n plus 1. Okay, please, it's very easy to remember. CnH2n plus 1 COO CnH2n plus 1. Okay, it's a reason why we say esters are also what? Carbonyl. They have a carbonyl what group in their formula. Okay, so now let's continue. If this CnH2n CnH2n plus 1 is what is R. Okay, so we could easily say that what? Esters have the general formula R. Okay, then COO, then what? R. Sometimes we put prime here for the case that the two R groups are not the same. So there's a very strong possibility that the two R groups are not the same. So that's why I put R and what? An R prime to differentiate them. But they are both what? Alkyl what groups. They are both alkyl groups. Take note of what? Of that. That's why I call them alkyl what? Alkanoids. So if I name me an ester, it will end with what? With the what? With the oid. Okay? Oids. Okay? So methyl methanoids. Okay? Or what? Alkyl alkanoid, and so on and so forth. So anyhow, what you want to name, you must what? End with what? With oid. So now we'll come back to this in a moment. Let us continue with what? With this. So now, how are esters formed? Esters are formed by the reaction between an alkanoic acid, with an what? Alkanol. Or alcohol, the one you call ogogoro, okay? In the what? To form what now? Esters plus what? Plus water in the presence of concentrated H2SO4. Okay, please do not forget that this reaction is actually what? A reversible reaction. Okay, it's actually what? A reversible reaction. So esters are formed by the reaction between an alkanoic acid and an alkanol or an alcohol in the presence of concentrated tetraoxovasis acid to give an ester and what? And water. Okay, so if you want to represent them, you could say what? RCOOH, which is the functional group or the general formula for what? For alkanoic acid. All right, then plus what? ROH, okay, which is functional group of what? Of the alkanol. Okay, so we have said it's a reversible reaction. So let's also represent it here. Okay, then we'll now get what? Our ester, RCOOR prime, then plus what? Plus H2O. Now, we have stated that what is a reversible reaction. So the forward reaction is what we call esterification. Esterification what reaction? You must have heard of esterification several times. So the forward reaction is called esterification reaction, while the backward reaction is called hydrolysis. Okay, this hydrolysis, we have two types of hydrolysis. We have what? Acid hydrolysis. We have acid what? Hydrolysis. Okay, and then we'll have what? Alkaline what? Hydrolysis. Okay, so please, we'll talk about what? We'll talk about hydrolysis in a moment, but for this class, the purpose of showing you this, just to tell you where we got this functional group from. Okay, so we get this functional group, all right, from the what? Alkanoic acid and from the alkanol, because that is what forms the esters. Okay, the alkanol and the alkanoic acid coming together is what gives us what? The ester. So that is definitely where we get our functional group from. So now, how do we get that? We get the what? The ROCO. We get it from the alkanoic acid. So if you take this like this ROCO is from the what? From the alkanoic acid. Meanwhile, this is an alkanoic acid. Then this OR, remaining OR that is here is nothing from the what? From the alkanol. O was R. All right. So if you say RO, I be OR, not the same. So OR. So now, that is how what we got our functional group for the what? For the esters. Okay, so that is what is settled. So the functional group for the ester is this, and of course, you know their name. They are called what? Alkanoid. They are gotten or they are formed from the reaction between an alkanoic acid and alkanol in the presence of concentrated tetraoxosulfate acid. So now let us continue. The simplest member of the first member of the alkyl alkanoids, okay, or of the esters is called what? Methyl methanoate. It's called methyl methanoate. Methyl methanoate is the simplest member. Methyl methanoate. Okay, is the simplest member of the what? Of the what now? Of the esters. Okay, now methyl methanoate has this formula HCOOCH3. Okay, if you want to draw the structure, I'm going to have C double bonded to O. This is the carbonyl group here. Then you have what's your H. All right, they now have what's your O again, this second O. They now bonded to what now? CH3. Okay, H. So this is our what? Our methyl methanoate. Okay, as you can see, the simplest member rather is what? Is HCOOCH3, which is called what? Our methyl methanoate. Now, another thing you should take note about esters is that esters have what? Fruity odor. Esters have fruity odor. Okay, they have what? Fruity odor, and that is why we use them for what? For flavoring. For flavoring. Okay, so they have what? Fruity what? Odors, and that is why we have used them for what? For flavoring. Please take note, it's very, very important. Esters have what? Fruity odor. That is why we use them for what? For flavoring. Now, a simple ester that we can possibly use to study other esters, a very simple ester we can use to study other esters is called ethyl ethanoate. Ethyl ethanoate. Okay, so it's a simple ester that can be used to study other esters. So if you want to study other esters, you can use what? Ethyl ethanoate to what? To study other esters. The formula is simply like this: CH3 COO C2H5. So this is our what? Our ethyl ethanoate. This ethyl ethanoate has what? It's a volatile. It's a colorless volatile liquid. Ethyl ethanoate is a colorless. Volatile liquid that has a very pleasant smell. Okay, it has a pleasant a pleasant what smell. All right. So ethyl ethanoate is CH3COOC2H5. All right, and it is what, a colorless volatile liquid that has what, a very pleasant what smell. So as we continue to want to talk about what esters, I'm going to be using what ethyl ethanoate as what as a very, very common example to explain what other what esters, or how esters behave, how they are prepared, how they react. Okay, so it's very important you take note of what, of that. So now, having known this now, this ethyl ethanoate also is sparingly soluble in water. Okay, it's sparingly soluble in water, but it is very, very soluble in organic solvents. Okay, like what, like ethanol. It is very soluble in organic solvent like ethanol and diethyl ether. Okay, it is very soluble in organic solvents. Okay, but it was apparently soluble in what, in water. Very soluble in what, in organic solvent like ethanol and diethyl what, ether. So now, having seen this now, it's now very, very necessary that what we just do a small introduction on how what we can name esters, because it's a very, very common question. Okay, so between the scope of this class, we do not want to diverge too much. Okay, let's just name what some simple esters, and then what we'll meet to talk about how to prepare them and the reaction that they undergo, as well as as the hydrolysis we talked about in the beginning. So now let's talk about how we can name some simple esters. How we can name some simple ester. Okay, let us look at them. All right, so now let us see. Let's see the first ester. Okay, that's methyl methanoate. We have seen HCOOCH3 as our what, methyl methanoate. As you see, we set out from arrow COOR prime to be what, our general formula for esters. So now we said that all these two arrow groups, they may be the same, or they may be what, they may be different. All right. So now for this case, if the arrow group here is hydrogen, that's where we got what, our simplest ester from, methyl methanoate. Methyl methanoate. Okay, if this arrow group is what, is hydrogen, that's how we have it here, and then this arrow group here is what, is a methyl group. Okay, so that's how I have methyl methanoate. And what do you notice? If we draw the structure of this methyl methanoate, you see it's what, C double to O, then you have O, then you have what, your CH3. Okay, then here what, our H. Okay, so now, what did you notice from the name methyl methanoate? Okay, you see that what, the methyl group is actually on what, on the right, isn't it? This methyl group is bonded to the what, bonded to the oxygen that is part of the continuous chain. This oxygen is part of the continuous chain, but this oxygen is what, is part of the carbonyl. All right, so this oxygen is one that is part of this continuous chain. So now the name methyl came first. Okay, before what, the methanoate. Okay, there's one carbon this way, there's one carbon this way. Okay, so now the alkyl group here is what, is methyl. We call this one first methyl. So it is the methyl group, it is the alkyl group that is bonded directly to the oxygen that is part of the what, of the continuous chain that what we measure first. Okay, so we measure methyl first, then we now come here. How many carbon atoms are in this way? You can say only one carbon atom. And from methane, there's a methane has one carbon. So from methane, we now have what, methane, met. So take for the met from what, from methane. We now have what, we now add our OH, because that is what their name. So now that's how we now have methyl. Then we now have our methanoate. It will become clearer when we see the second, when we see ethyl ethanoate. So ethyl ethanoate is actually, this is ethyl ethanoate. Okay, so we have a CH3COOC2H5. Okay, if we draw the structure, we're going to have C. Okay, then have our C, the bonded to O, our O. Then, okay, we're going to have our CH2. Okay, then have our CH3. Okay, these are what our ethyl ethanoate. Very easy. I just broke this C2H5 into CH2 and CH3. So I could actually have said just C2H5. Now, how many carbon atoms, the methyl group that is on this side, the alkyl group that is on this right-hand side is what? Is ethyl. because it is what? C2H5. C2H5 is what? Is ethyl. Now, the alkyl group, okay, now it's not really what alkyl group. Now, look at the number of carbon atoms that are here. That's 1, 2. Okay, 2 carbon atoms. So, and what? From our study of alkanes, okay, and an alkane that has 2 carbon atoms is what? It's an ethane. Okay, so if we now take what? Ethanoate, okay, ethyl ethanoate. So take what? Ethanoate, because what? An alkane that has 2 carbon atoms is what? Is ethane. All right. So now we take our name first. We will watch this oxygen that is bonded to the what? To this carbon that is part of the continuous chain. So this side we'll start with naming from first. So we'll take the alkyl group that is here, which is what? Our ethyl now. Then how many carbon atoms are here? 2. 2 is what? Ethane. So ethyl what? Then you now put what? The oit, which is in the way what to name what? Esters. So this one is now called what? Ethyl ethanoate. I hope it's getting very, very clear. Okay. So now let us see another example to portray what? Our naming system. All right. You see a lot of questions from past questions about this. So please, if you have not liked this video, what you are doing is very, very wrong. Okay. Liking this video will make other students easily find this video. You know what made a pass. So please click on that like button, share on Facebook, share on your social media platform, WhatsApp, your class group. Let everybody learn and keep passing. So now let us see another example. So let's say we have something like this. We have C double bonded to O. Then we now have what? Our O. Okay, yes. Then we now have our C H2, CH2, CH3. Okay. Then here we have what? H. So what are we going to call this compound? So it's very simple. Look at the alkyl group that is on the right. Look at this oxygen first. Observe where this oxygen is first. So now this oxygen is here. So now we'll look at what the alkyl group that is attached to this oxygen. So now that will be what now? C1, 2, 3. That is C3. Oxygen 2 plus 2, 4. 4 plus 3 is 7. C3H7. C3H7 is what? Is propane. Okay? It's from propane. So that is what now? Propyl. Okay, from the alkyl group that is formed from propane is what? Is propyl. Okay, because it has lost 1 hydrogen atom. So this is what? Propyl. Then of course, this on this left-hand side, how many carbon atoms do we have? Just 1. So you should definitely know that one is what? From methane. 1 carbon atom is what? Met. So now our oil will now come in. So to name this compound, it will just simply be what now? Propyl what now? Methanoate. Very simple as ABC. I be hard, you know hard. So I'll help you to answer the question. In no hard, waiting no good. Okay, so please, very easy to what to name. Let's see another example. This example, pause the video. Once I write the example on the board, pause the video, then what? Name the what? The compound. Once you have named the compound, you play it again to see if you are right. Okay, a lot of you may miss it. A lot of you may miss it. I will bet my money that some of you will miss it. So please, if you missed it, don't worry, just put in the comment section that I missed it, but I later got it. Okay, so now let us go. Let's say we have something like this. CH3. Okay, then we now have our O. Then we now have our double bond O. Then we now have let's say 1, 2, 3, 4. Okay, something like this. And so we have something like this. Okay, so we have something like this. All right, now what are we going to call this compound? We know we're using our stick form here now. It's very, very easy. Okay, so what do we do here now? Let me write this thing out again in what? In full form. So you have something like us. Okay, sorry. It has to be, it's bonded to carbon directly, not what? Hydrogen. H3C. Okay, let's say we have H3C. So I have what? H3C bonded to what? Oxygen, bonded to what now? Our carbon that is bonded to what? To oxygen. Then I have what? Our what now? CH2 here. Then this point, CH2. Then this point, CH2, then this point, CH3. So this is like the full compound. Okay, this is the stick form. So instead of doing the CH2, CH2, one, bang, bang, bang. So we have what? Expanded it. So now, how do we now name what this compound? Okay, so the normal thing we do is what? Is look at the left, look at the right. Now, where do we name from? I hope you have paused the video. Okay, so now make sure you have paused the video because I'm very sure a lot of you get it wrong. Now, our oxygen, which is part of the continuous chain, is on the left this time. It's not before. We'll be putting it on the right. Okay, now it's on the left. So now that means we're going to what? We'll definitely go to what? Start naming from what? From this what? Left. Okay, so the alkyl group that is on this left is what? Is methyl, CH3. So it is what? Methyl. Okay, now on this what our right right hand side, this carbon this carbonyl carbon, all right? How many carbon atoms are on this right hand side? So I'm going to have 1, 2, 3, 4, 5. Okay, 5 carbon atoms represent what now? Pentane. Okay, so that will be what? Pentanoate. So I'm going to have our naming to be what? Methyl pentanoate. Okay, so the reason why most of you will fail this is because you are used to what? Seeing what the oxygen on the right. So I used to see something like this, see the body to what? To O, then O. Then you now have what? Your like this. Okay, and B. So this is what you are used to. Okay, we are not used to what? It now being what? Here. So you must look at the position of what? This oxygen. Okay, where is it first? So that's where you start naming from. The alkyl group that is on that is bonded to this what? Oxygen is what you start naming from. All right. So please do not miss it again if you did. Okay, so now let us look at the final example, and we are done with this class. In the next episode, we'll continue our study of esters. Now, this is a very simple one. Let us just attach. Let's say we have what? A benzene ring. Okay, attached. Okay, so we have a benzene ring. Okay, now I have a bond to O. Okay, then I have your O. Okay, let's say we have something like this. So it's very easy. How many carbon atoms are here? 1, 2. So our oxygen is in your right as usual. Okay, so this will be our what now? Our ethyl. Okay, but this is what now? Benzoate. Okay, this is benzene ring. Okay, with what? With an ester with group. So benzoate, ethyl benzoate. Okay, so please, let us now go to the O3 School JAMB practice app and we'll take some questions, and we are done with this class. So please make sure you download the application. Make sure you keep studying. This is a 2007 question number 6. It is being displayed on your screen right now. 2007 question number 6. They said the IUPAC nomenclature of the compound by giving CH3, CH2, COO, CH2, CH3. Okay, they say what is the IUPAC nomenclature of this compound? So let's look at this, right? You can see what the oxygen is on the right. Okay, so now remember that this one now from this place here, this one is double bonded to O. Then this oxygen is one that is part of the continuous chain. Okay, so do not ever confuse it. COO. So now, what is the alkyl group here? That is what? Ethyl. This is C2H5, which is what? Ethyl. Okay, now this way, what is the how many carbon atoms are here? This is 1, 2, 3. That will be what now? Propane, isn't it? That will be propane. So our simple name here will be what now? Ethyl. Okay, and what? Propanoate. Very simple. Let's check the options. A say ethyl propanoate. B says propyl ethanoate. C ethyl butanoate. D methyl butanoate. Okay, correct answer there will be option A, which is ethyl what? Propanoate. So we're done with that. Let us now look at another question. 2013 number 47. They say an organic compound with a pleasant smell is likely to have a general formula. So they are testing out on general formula now. So correct answer there will be what? Obviously option what? A again. CnH2n plus 1. COO CnH2n plus 1. B is a ketone. Okay. C is a what? It's an aldehyde. D is a carboxylic acid. So now let us look at 2011 number 50. Okay, no, we'll come back to that question. Okay, well, let us just look at it quickly. CS3, well, the question is shown on the screen. 2011 number 50. We are giving an alkanoic acid reacting with an alkanol to give you what? An ester and water. They said the above reaction is best described as what? Obviously, is esterification. We talked about that in this introduction. Now, 2003 number 44, which seems to be the, 2003 number 44, the penultimate question. It says, the formula of ethyl butanoate. Okay, we're told to find the formula of ethyl butanoate. Okay, to write out the formula of ethyl butanoate. Okay, so we already know that what on the right, we have what? An ethyl group. And our ethyl group is definitely was C2H5. All right, so obviously, our option A and our option C are the only contenders. Option B is already wrong because there's a C3H7 at the end. Option D is wrong. There's a C4H9. So we should be having C2H5 at the end. Now, on this side, I'm going to have what? Our what? Butyl. Okay? It's supposed to be from butane. So I'm going to have 4 carbon. That's 1, 2, 3, 4. This one is carbonyl carbon. All right? So I'm going to have what now? That's what now? CH3, CH2, CH2, then C, then C. There's an O here, Abi. So then C, then O. Okay, O, C2H5. So now let us how many carbon atoms are here? C3. Let us compress this. C3, 1, 2, 3. C3, so C3. Okay. How many hydrogen? 3 plus 2, 5 plus 2, 7. C3, 8, 7. COO, C2, H5. Okay, so that will be our what now? Our ethyl butanoate. Our correct option is option what? Look at the options very well. Option A is very correct. Okay, hope you understood what we did. So it's not C4H9. Okay, C4H9, COO, C2H5. No, it's not that. This is our carbonyl carbon. All right, it does not have what hydrogen bonded to it. Okay, it does not have any hydrogen atom bonded to it. Okay, so it's bonded to what? To oxygen. A carbonyl. This the bonded to oxygen and what? Single bonded to another what? Oxygen. So this side is what? Is carbon. Okay, so please you must take note of what of that. That's why our correct answer there is option A. Okay, we have another question here. 2023, number 1. What is the characteristic odor of most esters? The characteristic odors of most esters, I talked about it. We said that esters have what? A fruity odor. Okay, and that is why we use them as what? As flavoring. So our correct answer there will be what? Option A. Now, there are many other questions on this application. Download, activate, enjoy yourself, pass. It is your will to succeed. You will succeed if you are studying vigorously with this application and are following our lecture series. My name remains Master T, the Grand Commander of this O3 Schools Army. Make sure you want to follow me on all social media platforms and keep joining us in our studies. We'll see you in the next class. We'll continue our studies on esters. Thank you for watching. See you there.